Up till now, we've been looking at the correlation or the association or relationship between two variables. It's possible to actually include more predictors than just one. This is called multiple regression, and we're first of all going to explain a little bit about it, and in the next video we will demonstrate that on SPSS for you. Here's the regression equation. Y hat is equal to B1 times X1 plus B2 times X2 out to as many predictor variables as you have, plus a constant again. The B values here are just like the B value in a simple correlation. It's a coefficient that you multiply times the value you have on each of the variables.
Here's some figures representing what goes on with multiple correlation. Notice here we have a box representing variance, and we have a single predictor. There's a fair amount of error then in this prediction. Let's add a second X. And what happened? Oh, we have reduced the amount of error because we've gotten another variable that tells us something about variation in the Y variable. How about another variable? And suddenly another variable. So as we add variables, you would expect that you'd have a higher overall correlation between the sum of the predictors and what you're trying to predict. But there will always be some overlap amongst the predictors, so you have to be careful about that. You want to add variables because adding variables generally reduces the error in prediction. But you want to add variables that provide new information. For example, if you have a skin fold on the right triceps, don't take a triceps skin fold on the left because they might have a lot in common. If you have a triceps skin fold, maybe take a skin fold from their leg and another skin fold from the trunk. The idea being that you gather new information.
Now this is the example that we're going to show you in the next video. This is the data that we have been using all along where we're predicting percent fat. Now we're going to add age to that and skin fold and BMI, which we've seen before. We will show how to do this in the next video with SPSS.
Some of this information you've seen previously. We see the correlation between skin folds and DEXA to be 0.829 and BMI and DEXA to be 0.542. We now want to add age. Let's see if we take the combination of age, skin folds, and BMI and see if collectively it reduces the amount of error. You'll notice in the table on the right, the model summary, the multiple R is now 0.8